Hello. In this lesson, we'll be talking about how thermal energy is transferred. How is thermal energy? How is thermal energy transferred? Transferred. Before I open the slide, I would like to make a difference between heat and thermal energy, because some students are getting confused about what heat is and what thermal energy is. Heat means to cause something to get warm or hot, to get something to cause something to become warm, or hot. That's what heat is. Now, what is thermal energy? Thermal energy, it's relating to it is relating to something caused by heat energy. It's relating to or caused by heat. When you talk about thermal energy, thermal energy is related to something caused by heat. Now let's say, for example, you have a pot on a stove, on a cooker, and you're applying heat. Let's say you have the particles of the water you put inside the pot getting together this way. When you have heat here, the heat you apply here sends energy to the particles here and makes them to vibrate vigorously more than the way they were vibrating before. So now you say thermal energy is transferred. We say thermal energy is transferred. Now I hope you can know the difference between thermal energy and heat. Okay, let's move to the slide I want to work on today. I want to talk about the types of heat transfer we have and how this heat is being transferred from one body to another body. Excuse me. Now the first one we'll talk about in this class is we need to understand heat transfer. We have to talk about conduction. We have to talk about convection. We have to talk about radiation. Now here, heat transfer, heat always moves from a warmer place to a cooler place. That is to say, if you have a material that means it's warmer than another material. Let's say you have a hot tea cup, you put it in beside an iced tea cup. You find out that if they're put together, there will be a transfer of heat energy from the warmer cup to the cooler cup. So that tells you heat transfer is from the warmer body to a cooler body. Hot objects in a cooler room will cool to room temperature. If you have an object now in a cooler room, for example, let's say in a room here, we have something which is hot. We have a hot cup in a room here. Then you find out that there is a tendency that the coolness of the environment will influence the hotness of the object. Means there will be heat transfer from that hot object to the cooler room. Cold objects in a warmer room will heat up to room temperature also. That is to say, you have a cold object in a warmer room, it will have to heat up to get to the normal temperature of the room. means it has to maintain stability. There must be a maintenance of stability in the temperatures. That is to say, if you have an object colder than another object, the object which is colder must get some heat or warmth from the hot object so that the temperature can become the same thing. So the next one we want to talk about is this. If I have a cup of coffee and a red popsicle were laid on the table in this room, and what will happen to them? Why? You find out that the cup of coffee will cool until it reaches a room temperature, and the popsicle will melt, and then the liquid will warm to room temperature. Now you have a cup of coffee, which you know it, of course, the normal environment in which you put a cup of coffee it's a cool environment. The coffee will have to cool down until it reaches the room temperature, that is to say the balanced temperature. What the popsicle will melt, because the heat energy leaving from the coffee will have to be transferred into the popsicle and will make it to melt and turn to liquid so that it could maintain the balanced temperature of the environment. Now we have three basic ways in which it could be transferred. The first stage is the conduction, and the next one is convection, and the last one is the radiation. Now let's talk about conduction first. When you heat a metal strip at one end, the heat travels to other end. What we're saying here is this. You have let's say you have a spoon which you used to eat at home. You're putting it inside hot water, or maybe you're cooking at home. Then you left the spoon in the cooker. Then after some minutes, you forgottenly you want to pick up the spoon. You find out that the spoon is going to burn your hand because there's been heat transfer from the warmer or from the pot in which you're cooking in, from the part of the spoon touching the warmer to your hand. As you heat the metal, the particles vibrate. This vibration make the adjacent particles vibrate also. So and so on. The vibration pass along the metal, and so it is the heat. We call this conduction. That is to say, the heat transfer when particles or when substances touch another substance is called conduction. That is to say, two bodies must have to touch each other before it can be transferred through the process of conduction. Now the next stage is we want to use a metal as an example. Metals are different. The outer electrons of the metal atom drift or are free to move. If you've not forgotten, in the last lesson I told you guys that the reason why neutrons and protons don't move is because they are enclosed in the nucleus of the atom. But the electrons is outside the nucleus, is around the shell area, and that's the reason it's free to move. And that's the reason whenever you're talking about transfer of heat energy, you're talking about the transfer of electrons from one body to another body. When the metal is heated, the sea of electrons gain kinetic energy. Means the electrons which are gathering in the body will gain kinetic energy and transfer it throughout the metal. That is to say, they gain energy because they're trying to move from one place to another place. So this energy is transferred from one body to another body, or from one part of the metal to the next part of the metal. The next one we need to talk about is insulators. When you're talking about conduction, you have to talk about conductors also. Conductors are materials that permit heat to be transferred or electrons to be transferred through them easily. While insulators, such as wood and plastic, do not have the sea of electrons, that is to say, they don't have electrons in them, and which is why they do not conduct heat as well as metals. But in some rare cases, we don't say they don't have electrons in them. They have both electrons and they have protons in them. But these electrons are not permitted to transfer. They are not permitted to move from one location to another location in them. And that's the reason we call them insulators. And that's the reason we can use them to conduct heat and electricity. We're going to stop here for this lesson. We'll continue in the next lesson. Thank you very much.